Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. This is part 17 using CLC. Please like the video and subscribe to the channel, most grateful. So we're going to use CLC, Configurable Logic Cell. That's right, yeah. This chip has got, I think, 8 of them. We're going to use one just as a way of showing you how to configure it with ease. So I'm using a PIC17 demonstration board. Looks like this on my camera. We've seen this many times in the tutorial. I've got a Q35 here, and I'm going to use some LEDs that are attached to the top. Oh, and I'm going to use a switch here. This board is well documented. Sorry, go back. This board is well documented in the PDF. I don't need to go through what that's all about, but the LEDs are attached via suitable resistors. But we're looking at inside the microcontroller, looking at the CLC functionality. And basically you can implement custom logic directly in the hardware. There's no CPU intervention. This is direct control of inputs and outputs. And you can create logic functions with very simple configurations. So I'm going to show you something that is really simple. It's actually quite useful because there is no code involved to give the user feedback that they've done something. So it has logic gates like ANDs, ORs, XORs, etc. You have flip-flops and sequential logics, and you can use many different input signals. I'm going to use a switch, but you could use that from timers into other interrupts. And the outputs can be routed to other places, like other peripherals and other inputs and outputs, and I'm going to output it to LED or LEDs. So you could generate a custom pulse width modulation signal, which I've done many times for LED, WS2812, for instance. That it has a custom signal, and I can generate that from CLC. You can do DSM or data signal modulation. You can just create your own protocol. But you can use it for LED controls as well. And I've used that extensively personally in major projects. Look, CLC is quite scary to start with. But what you've got basically this diagram on the right. This is my diagram. You've got ways of getting signals in. Let me bring the pen up. You've got inputs. Whatever those signals are, they get routed through to logic gates. And I've listed a few logic gates there. You can AND things, you can do ORs and XORs. You decide what you want to do with the logic, and then you push it to an output pin. And that's all that you're going to do. It's extremely simple, but it looks very scary. You've got this beautiful diagram, digital logic diagrams, and essentially what you've got is a set of inputs on the right-hand side, on the left-hand side even, left-hand side here, left-hand side, and you select those via PPS. And we've seen the PPS tool. You then wire up, and I'm wiring it into this gate here, and it's coming through, and I'm flipping it over here. So I'm going to knot it at the output. So how do we get that inside of GCBASIC? That's the trick. With ease, because you don't really want to be hacking around the data sheet trying to figure out all this stuff. So I'm going to create an example. I am going to show you how to use the microchip standalone MCC. And we're going to take some files from that. Let me just bring my pen up. We're going to take some files from that, from the configuration that we've created, and we're just going to plumb it straight into GCBASIC. And that's really it. So in GCBASIC, you just do the basic hardware, you merge the contents and test and enjoy. It is extremely simple. So the first thing we need to do is go to this URL, and which I've listed here. Where is my pen gone? This URL, and we'll go and get the MCC, install it, and see what happens. Okay, let's get started. Well, let's go to that URL. I've already been there. I'll put it on the screen here so you can see it. There we go. This is the microchip download page in that URL. Here it is, download. You go down here and there is a number of downloads and it's plug-in, but you've got this thing called standalone Windows, Mac, Linux. So you've got 3 ways of doing this. Just download it, install it. It's a complete no-brainer. Let's see if I've got it installed. MCC. There it is, look, MCC standalone. For those who can't see it, I'm reading it out, 5.7. There'll be other versions of it, obviously. And here it is. It opens up this beautiful white screen. Very scary. So what I'm going to do is just rescale that and zoom in for you. Okay, then just move it about so we can see it on our screen. There we go. I am going to have to zoom out shortly, but I want to get this piece started. All I've done is install it and accept the defaults. So it says you have to accept some Java stuff. Just accept it. That's a necessary evil. File, new standalone configuration. Take the defaults. Don't get too clever. Next. I've already done this, so it's asking me to overwrite it. Then overwrite it. What you might want to do is remember where you put it. So let me just cancel that. File, new standalone configuration. I am going to take a copy of that into my cut and paste buffer. Control A, Control C. Next, overwrite. And it now looks at what the devices are that are installed and you can manage. Well, I'm managing a 46Q35. Oh, Q35. And it matches it. Press OK. It will now load some libraries. It might, on your first load, it may go and get some libraries. But all that worked seamlessly when I installed it yesterday. It's just initializing the project, initializing the content, and you end up in this beautiful window, which is a bit scary. But let's not be scared. Let's look at what we've got here. I'm going to make it slightly larger and shuffle it about. Here we go. I think we're there. Okay, what have we got? We've got a set of pins at the bottom, which is for the this set of pins at the bottom, port A, port B, C, D. We're going to be using those because we need to be making some selections. We are only interested in CLC. So what we've got are some blocks, some components here in the middle, and some on the right-hand side, a dialog that we'll be looking at. It's a bit scary, but all I need you to do is to select device resources on the left. There's a small tab on the left, click. And then it says, I've got some libraries, some drivers, system, and some peripherals. Well, if you look in the library, this is called the CLB. I won't be covering that in the tutorial, but basically custom logic blocks. Drivers, look, CLC is listed. Open it up, 8 CLCs. We have to pick one, and I'm going to pick number 1, then I'm going to delete it, then pick number 2, and I'll show you why. Number 1, I'm going to add it in. I've added it into my configuration, and I need to output my LEDs on port B. And if I look at down here in this pin module down the bottom, CLC1, I can't select port B as an output. Look, output CLC1, it's quite clearly marked here. Look, CLC1 output, I can't select port B, so that's not going to work for me. How do I get rid of that? Go back to Project Resources tab and just remove it. Back to the tab, the vertical tab, Device Resources, CLC2. Does that work for us? No, port B is not selectable. Back to the resources, kill it. Finally, CLC3. Look, it gives me the outputs on port B, and I want to select as my output. My LED output is going to be on those two. There you go. And my input, CLC, is going to be A4. That's where my switch is. And that's in the layout in the code that we'll see. So I am going to push a button on A4 and two LEDs will come on over there. But how? That's the question. So what it did over here on the right hand side, it's added in some other, it's made that side active. So if we go back to this tab, Project Resources, CLC3 is now selected. Okay, I'm going to go to full screen and I'm going to zoom this application out. If I drag this across, this right hand side across, look, here is that diagram we were looking at in PowerPoint. First thing I need to select is I need a gated OR or XOR. And here it is, here's the diagram. I've got my CLC in 0. CLC in 0 here, selected. CLC, and that's what I selected in the pin input. Look, CLC in 0. Down here on the, I've selected A4. So the PPS indicates that PPS will be controlling it. So it's CLC in 0. I'm going to connect that and I'm going to toggle the output. So it's a NOR. So basically that's it. So all the stuff done. Then I am going to zoom back in for you so that you can see me do this part. Just rescale this application. And it says at the top here, generate. And just it's generated a load of code. And if I look at the user output, it says down here, generated a load of code. That's it. Let's go hunt, see what it's generated. Well, in my Explorer, but I'm going to use GC Code to do this. Let's use GC Studio to do all this stuff. Let's do that then. I'm going to open up GC Studio and get started. Press Windows, GCS for GC Studio, and it will start up. I will ignore the update. And it's taken me into, oh, that wasn't very good. It's taken me into GC Studio, and I'm just going to open up my local folder, and this is vendor boards, microchip PIC17 18F. Select that folder. I'm in the IDE. Okay, let's open up this file. Open file. We're going to look at some of the outputs. Oh, this is the folder that's in my cut and paste buffer. I'll zoom in for you. Bring it across. C/users. I'm called admin.mcc, and that's where it puts the output files. So it's your username, users, admin. Or any folder that you selected. I don't know where you're going to put it. Okay, and these are the files it just created. All the time sort of match up here. Okay, all right. Let's go to that folder, and here it is. Here's the folder. So I've just selected MCC generated files. They're very simple. The first thing I want to select is CLC, because that's what we were playing with. CLC, we'll look at the source it generated, and we're just going to open up CLC3.c. It even tells you the CLC you were using. And in here, I've pre-selected it, look. It's got a load of C code. Look at the desktop, load of C code. Basically, you want this initialize. Just select the initialize function, copy it down to the call register. Just take the big block of register. This is setting the registers. Setting the registers, very simple, okay? And what that is essentially doing is going to set all the registers for us. Control C. I really ought to open, though, a GCBASIC program to paste it into. So let me just open up my project for today. Control B. I want program 270 using CLC. Well, I'm just going to take out all the code that's written here, okay? Take it all out. There you go. All gone. I'm going to paste in now that CLC code that I just took from that other file, that C file. Now, in the latest version of the tool that Microchip have written, for some reason, and I don't know why, you'd have to ask them. This is the register name and this is the setting. They've now put this is called a cast. They're casting that variable, that result. I have no idea what they're doing. Just select it and just remove it. If it's there, just remove it. Gone. Because we're not using casting. We know it's a byte, so don't be silly. I don't know why they're doing that. So that is the CSC. That's the CLC configuration done. Done. Let's go back to what else it gave us. Open a file. Where were we? We were in. I want to go back to the MMC folder. Generated file, system. Open it, click. Look at the source folder. And in there, there's a file called pins. I'll zoom in. Pins. So that's in MCC generated file, system source, pins.c. Open that up. Oh, you can see I've been in here before. Just grab the PPS registers. Just take them out. Copy. Take them out. That's what you need. Take them out. Go back to our source program, and I'm going to stick in some PPS. You can do that in PPS tool, but you'll be there for about an hour doing it, okay? And you know it's going to work because we've taken it directly from Microchip's tool. So what we've got is the PPS section lifted directly from Microchip's tool, and we've got the CLC section lifted directly from the tool. The rest of this program says, here is my chip, here's all my constants, and there is no program. Look, no code, no interrupt, just CLC magic. That's what I've written. Look, I haven't tested this, but we ought to test it now, really. Let me bring up desk cam so we can see it. There it is. I'm going to program the chip function key F5. Let me just check. It's all hooked up. It's just waiting for it to program it. And if it's worked, I've got RA4, some LEDs up the top here. When I push this button here, the LEDs are going to come on. Look. I'll put my hand there so you can see it, look. You go, that's not working. Well, it is, because we're going to change the code and we're going to put something in here that goes. There's a switch, isn't there? Yeah. I'm trying to think how to do this, okay, to show you that it's working. Oh, I know. If I put LED 2 in, is it LED 2? LED 2. Yeah, there you go. LED 2 equals not. Have I got the other switch hooked up? I'm trying to think of a way of demonstrating this because it's like so convincing. Look, it's worked. I don't know how to show you really because now I'm just trying to think how you can do it. If switch, we got something called switch, haven't we? If switch, I can't remember what the constant's called here. Let me look at the switch. Oh, there you got it. I'm going to do it like that, look. I'm going to set it to the inverse of that. So what I'm going to do is that if the switch is turned on, I'm going to light up one LED and it's going to be the inverse of what the state of the switch is. And that's just a way of showing you that there is some logic running that is independent. So CLC is totally independent of the logic. Okay. I've got 3 LEDs on. Oh, that's interesting because, of course, it's toggling it. Ha! It's toggling it. That's brilliant. But basically what I'm showing you there is some code here that is independent of the CLC. Delete that. CLC is working independent of the code. There is no code. Microchips say there is no code with CLC. That is not true entirely, is it? Because we know from our little experiment here, to make this work, 1, you have to set the PPS. 2, you have to set the registers. Well, I'm sorry, that is code. Recap. Use the MCC tool. It makes absolute sense to use this tool. You would be crazy to struggle, yes, to use any other method. It is there for that purpose. That's why they wrote it. You could write a converter if you wish to pull the code in automatically, but essentially find the code, find the CLC code you need, extract the initialization out. The rest of it is not important, by the way. Extract the PPS to make sure it matches what you've designed in the designer, in the configurator, and paste the code in. Job done. CLC is generally easy to use when you have the right approach. I am going to start to wrap this up with the GCBASIC toolchain. In the next tutorial, we are going to cover quite a lot, but I am going to continue on. I'm going to talk about some assembly, alternatives, MPLAB, and other things, but I need just to go through the toolchain to understand, so you understand the full set of tools are available. Do enjoy CLC, because I do.